lot to get through today. All right, let's wrap it up. Let's start class, guys. I know some of you have started the problem already. We have a surface that's bounded above by the sphere, x squared plus y squared plus z squared equals 1. Below by the cone, z equals square root of x squared plus y squared. We want to do this in cylindrical coordinates for the practice, really. So how do we go about doing it? Well, we need to have it's a volume, so the function is going to be a 1. And then we need to have r dz dr d theta for our differentials. So we need to figure out what we're doing for z, r, and theta. For z, I just wrote them both in terms of solve each of these equations for z and replace x squared plus y squared with r. And so you'll have z equals r, and the upper limit is 1 minus r squared. Then once z is integrated, the whole thing, when we integrate z, we're done with the vertical surface. Everything's just projected downward. So we're looking at the biggest ring right here is where z, the two surfaces intersect. That'll be our projection onto the xy plane. So we got to figure out what that looks like so we can do the cylinder part. It's easy to assume that the cylinder is going from 0 to 1 because the sphere is, but recall that the sphere is actually coming out further than our actual ring, or our projection is. So it's coming out further than the projection. So we have something different. Set the z's equal to each other and solve, and you're going to get r equals √2/2. After that, now it's just integrating. It is not separable yet because z is a function of r. So we integrate. We've got RZ dr d theta. I've got r times the square root of 1 minus r squared, and then minus r squared. And I think I want to separate this out. I think I want to do another integral with r squared over here. Because this needs to be dealt with together, and having that r squared, because it throws it off a little bit. So if we do a u sub, so we're going to get a -1/2r equals dr. And I've got the r, I need the -1/2. What happens to r? R goes, the bottom one is 0, so the bottom limit, when we plug it in, u equals 1. And r squared is up here, it's 1/2. So 1 minus 1/2 makes the upper limit 1/2. And now I've got square root or u to the 1/2 du d theta. And we still have our other one, but we can start integrating that now. 0 to 2 pi 1/3 r cubed. I could change the sign here by flipping this integral. I'm lazy. I'm not even going to do that. I'm just going to integrate. So up the power is 3/2, divided by the power is divided by 3/2 or multiply by 2/3. I've got u to the 3/2 from 1 to 1/2. And then I've got the integral of 0 to 2 pi d theta. So I can separate it now. Over here, we do that again over here. We got minus the 0 to 2 pi d theta. And we evaluate this. We've got, this is really, we'll go with it. I get 1/3. Cubing the top is the root 2 to the third power would be 2√2. Cubing the bottom is 8. And then we've got minus 0. That's going to simplify a little bit, but I'll do that on the next line. So I got minus 1/3. 1/2 to the 3/2 is 1/2√2 minus 1. And 0 to 2 pi d theta, we've seen this enough times to know that just boils down to 2 pi. And here I can do some simplifying. I'm going to get √2/12. And this probably cleans up a little bit, right? If I multiply the top and bottom by √2/2, I get √2 on top, 4 on bottom. And I'll put the 2 pi over here. And I think I should just get a common denominator 12. So I got -2 pi. This will give me a 12. I can make this 3/3, so or 4/4 when I multiply it in.
I can kind of see where you got the then you got that from this one.
So I've got -2 pi/2, and another -2 pi/2 is -4 pi, not over 2, √2/12 minus or plus 8 pi/12. And I guess that does simplify. We can simplify all that around.
You just take the R out.
So I'm going to write it up here what we get. I'm getting 2 pi/3 minus pi√2/3. Is that what you guys are getting?
Oh, that's why.
Unless I fucked up somewhere. That's an ugly answer.
This is just going hard for the one. See how it's early line? Or
So you already integrated it?
yeah, because it was originally just on just
So this is what you have.
yeah.
So originally, like, originally R. And we put this in there.
Yeah. And you go from
That makes more sense. It needs to make a lot of sense.
Oh, it's got something different. No, it doesn't. 2 pi/3 minus
If you simplify, same.
Yeah, I was checking the answer key real quick. Making sure that I got the same answer. All right. Yeah, I simplified this up to this. Any questions on that? It's a lot of tedious work once we get out of the, put it in cylindrical. Which is why maybe this problem isn't the best idea to do it in cylindrical. This is probably a better problem to do in spherical, so why don't we do that?
What?
Practice.
Let's do this in spherical.
We're going, we have the best.
We already know what the answer is, so we should know, we should get the same answer, right? That's
After
how
all,
it-
it's okay. It's an ice cream cone. You'll love it.
No, if you don't like ice cream.
Um,
Paying $5.
Just imagine it's frozen yogurt instead.
You just
So-
ice cream.
Now we gotta figure out what this is.
Everyone looks like.
The theta is still gonna go from 0 to 2 pi, right? We're still going all the way around the circle.
It's
It looks
pi
like
about-
we're going from row here to out here. Row should go from
Imagine
0
it's a cone of frozen tears.
Imagine it's just.
What's our
If
angle
you're
though?
in the shape of an ice cream cone.
So for phi, the cone is gonna define phi. I've got z equals r.
It's just in time for the.
Wait, was that
cone
full?
of
That
ice
was
cream
after.
cone.
Maybe.
R doesn't really help us here though, does it? When I look at it along, if I set like y equal to 0, y equals 0, z equals x, which means it's making a 45-degree angle. Same thing if I do x equals 0, I get z equals y from the cone. So it's making a 45-degree angle. That would be pi over 4 coming off that axis. So phi should go from 0 to pi over 4. And now all my limits got really easy. Let me move this little sketch over here.
Hey, Professor Jones, sorry, I got in here late. How were you given row, or did you find row, or?
Rho is
Like,
from, I'm getting it from this equation right here, the equation in the circle.
Okay.
That's a good question. I kind of raced through that. That's telling me that rho squared equals 1, so rho equals 1.
Yeah.
Oh, yeah, okay,
Yeah, because in this case, we're using spherical coordinates.
okay, for sure.
Good question.
Thank you.
And then we've got phi, and we got that going from 0 to pi over 4. And we've got rho going from 0 to 1. But now, and we still got the function, we're doing volume, so the function is 1. But now the rest of our integration, we need a rho squared sine phi d phi d, I'm sorry, d rho d phi d theta, where rho squared sine phi is the correction factor.
So that's like your R for cylindrical, but spherical.
Yeah, exactly. It's like our R in the cylindrical.
My pocket's upside down.
Yes, and you gotta make sure to turn off the door as well.
What?
Jericho was saying that his pockets were, what was it? He said
Upside down.
his pockets were upside down. So I was like, yeah, you gotta turn off the door as well.
So for easier to remember it,
I don't know that there is an easier way to remember. It's something you have to remember. I mean, you can derive it. In 14.7, you'll learn how to derive it. Pain in the ass to derive the correction factor. But in 14.7, we'll actually have the tools to derive it. So this is actually separable. All my limits don't have their constants. And none of the functions are, there's no plus or minus, these are all products. I can actually split this up into 3 single integrals.
How we did that. Yeah. Based on that point of view. Word actually.
Feel my legs.
So he did this because there's no, all the boundaries for the integral are all, no, they're all actual numbers.
Yes, if one of the integrals would say like 0 to b, he couldn't do that. Because a bound was in terms of another variable of the function. But because they were in terms of themselves, or rather in terms of numbers that define themselves, he could split them up like that. He couldn't split them up if it was, say,
Like if we had row in
I can't split it up if it's like this. If there's addition or subtraction in it, I can split it up normally, like separate it into 2 different integrals. But there's got to be addition between them. When it's just a product, and none of these are functions of the other letters or variables. And I know they're not functions of the other variables because my limits of integration aren't getting me that either. If we had one as a function of another variable, I mean, I could write them as a function of the other variable, but that's silly. We deliberately, that's what we had when we were doing cylindrical. Cylindrical, we got stuck with Z as a function of R, but shifting to spherical allowed us to get rid of that dependency. So as long as you have F, G, H inside with the 3 integrals, you can break it up into integral F, integral of G, integral of H. If it's F, G plus H, the shit doesn't work. So it's a handy dandy little shortcut tool. Fubini. He's got a great name. Fubini.
oh wait, that's the Beanie theorem?
Yeah.
Oh my God.
There's some great names in mathematics. There's L'Hopital is a great name. Fubini just rolls off the tongue so well. Dirichlet, you differential equations, you'll learn about Dirichlet's boundary conditions. And then there's the famous one in applied mathematics. His name is Lipschitz. No joke, Lipschitz.
I mean, we just learned literally someone's name was, and the theorem was like the drawn face or something. It's literally legend and then Ray.
All right, you guys ready for another problem?
Yeah.
When did you get back yesterday?
I mean, I'm already doing it. So that's what it's-
Yeah.
I'm so slow.
Let's do this one.
I was so tired. Hey, but it was fun. It's fun.
Oh, that's awesome. Are you doing the other one?
I'm still doing the other one. Because I didn't. Yeah. And I want to combine these. I want to be separate, but I don't want to.
Yeah,
You say I'm
really,
multiply.
they don't, you can multiply.
That's
them.
gonna be, that's gonna be.
What we should do?
No, I want to multiply that by. Two.
Go ahead and talk, Eric. I'm trying to hear you over Jared. Jared doesn't have a low volume.
I mean, we should be convert to cylindrical or spherical.
Well, that's us for us to decide. Let's take a look at the boundary conditions and see what we get. This is suggesting to me, just looking at it, this suggests to me spherical. But let's take a look at the boundary conditions, the limits. So if I do 0 is less than or equal to z, less than or equal to square root of 1 minus x squared minus y squared. This is getting me z squared is less than or equal to 1 minus x squared minus y squared.
I got the right answer. Let's calculate it.
So x squared plus y squared plus z squared equals 1. This limit, the z limit looks pretty good for spherical. This looks good for spherical. When we look at dy, dy is just positive. Y is greater than 0, right?
Its version.
Y is less than square root of 1 minus x squared. So we square both sides. This is going to get us x squared plus y squared is less than 1. Does that match what we were doing earlier? We have a sphere.
Okay, got it.
And we get rid of, like if I projected the sphere onto the XY plane, on the XY plane, I would have 1 x squared plus y squared equals 1. So this is matching the sphere. Matches projection of sphere. And -1 to 1, that also matches the sphere. I'm rotating the fucking thing as I write, sorry. The -1 to 1 on X also matches.
Hey, real
So
quick.
this looks like, yeah,
For your limits of integration on the very right side, for your -y that's under the square root, the exponent, is that an x or is that 2? That's 2, right?
it's a 2, 1 minus x
Okay.
squared. And that's the same up here. So what we really, so we have the full range on X. We don't have the full range on Y though. So what we really just have is that the hemisphere that projects from the XY plane, if this is the XY plane, it's going like that. We've only got half the circle. And it's kind of hard to sketch the correct, well, maybe I should do it like this. If X is coming out of the board, this is Y, this is Z, and X is coming at us, then we have that. Which means I don't have the full range of Y. So how is that going to limit our thing? The radius is still going to go from 0 to 1. It looks like phi, because phi starts at the top and rotates down. The phi does its full range. So it goes from 0 to pi. It looks like theta is the one that's reduced. So in terms of the XY plane, if I look at it as X down here, yeah, this is a shitty way of doing it like that. Let me do the 3D. X is here and it's rotating, going this way to the back half of X.
I did get the spherical one.
So theta is going 0 to pi as well. It doesn't go the full 2 pi.
Are you, did you record this?
Yeah.
Yeah, it's
Recording.
Is it?
Yeah, we're
Yeah.
recording.
That's good to know.
Oh yeah, okay, good. I don't remember hitting record. Fuck, that's a good question. All right, so the two angles go to pi and the radius goes to 1. I'm gonna do that up here. Just let's write that out now.
I should be able to do it. It's, you know, I just remember the-
So what happens to our function inside the integral? We get e to the negative
RDR.
rho squared
Polar.
to the 3 halves.
It's spherical, it's rho squared sine theta. I think.
Sine theta.
And then we have rho squared sine phi d phi d, I'm sorry, d rho d phi d theta. What does that clean up to? What does this clean up to? Because that's fucking ugly.
Negative rho third power.
Is there?
So we take the exponents and we multiply them. This should clean up to negative rho cubed.
So that one is the
I think you said that.
rho. No, so that one is the rho.
There's a problem up there. Make sure everything's matching up good.
That one is with rho.
I'm going to move this to the left a little bit so I can write.
The theta is the same as the regular theta you get in the phone. The B is taken from the top axis, so you usually run a Z.
So I don't like that negative rho cubed. Let's deal with it. Let's do it a u.
Usually is that's it. So
Consider rewriting. Rewriting. It's equivalent.
So I still have 0 to pi, 0 to pi.
Kind of like imagine like your theta where it goes around.
When I plug in rho equals 0, I get u equals 0. That's good. When I plug in rho equals 1, I get u equals negative 1.
Not hard to say.
And I got a negative 1/3 e to the u. The rho squared, I got to eat the rho squared and the d rho get eaten up to make du. So sine phi is still there. Now we've got du, d phi, d theta. So the red part is what changed there.
Yeah,
Or I hate to use so.
yeah, just.
So this has become separable. None of the functions are in terms of anything else. It's a product. I'm gonna put the 1/3 out front. I got 0 to pi d theta. I got 0 to pi d phi or sine phi d phi. And the negative, I'm going to deal with the negative right now by flipping that integral.
I don't know, but they're not gonna ship.
You guys have time to study for it. All my time struggling. Yeah. I wasted like 3 hours trying to figure it out on my own. And then I asked for help and they were like, oh yeah, on this. And I was like,
Trust me, they're not getting it, like this, folks, they're not getting it most of the time.
it was actually awesome more than I thought it was.
It's a lot simpler and it's a lot more complicated. Trust me. Yeah.
Can you stop, like when you write things, can you just not like erase it and then replace it with you, like, I mean, this is a simple instance of it, but like when you have u equals negative rho squared, and then you bring it down, can you just leave like all the lines that you do instead of erasing it and replacing it with what you, like, does.
Yeah. I tried to,
And that's a real simple instance, like the u equals negative rho cubed or whatever. And then you just,
yeah.
like,
I'll write
obviously
my-
that's pretty easy to see what you did, but like sometimes it's not as clear. And then you've erased the line and just plugged it back in. And then it's like, when you're looking back at your notes, you're like, what happened here? Because you're not remembering,
Okay, I can do that. I was trying to save space on this. I wouldn't be, as a student, I wouldn't save space on this. You're right. So I'll just use more whiteboard. It's okay.
Thank you.
Thank you for pointing that out. I have no problem doing that.
Just have to buy a bigger whiteboard.
No, I got plenty of whiteboards here. I just gotta use them more. This is
Yeah.
negative 1 plus 1. And this is 1 minus 1 over e.
Learning it. I just do my work until it's done.
And that's one way of doing it. It's just. Yeah.
There's nothing to manage. You just use the time you have.
I get that.
You can always switch between things too. Your stuff.
Hardwood.
Oh, we really are.
It's negative 1, it's 2.
Oh.
It's negative 1 plus 1 is
Implying I with negative 1.
I love that.
Oh, no.
No, I just kind of buy it.
No. The reason the second one is because cosine was already negative anyway, so the first one's minus the last second one. Also, that's. Isn't cosine of pi? Wait, sine of pi. Oh, I'm thinking of pi over 2. That's fine. Sine of pi. Sine of, yeah, all right. Yeah. 14.2 is.
I'll leave that up for another 30 seconds or so, and then we're gonna switch to looking at 14.7 next. 14.7 is on the Jacobian, so we'll just do some practice Jacobians and actually do problem solving with Jacobians tomorrow.
Just means it's
Anyone need this out longer?
Give it a
Yeah,
bit.
you're not-
Eric looks like he's finishing up as well.
Then again, if you read the book, you're still struggling. That's for some.
Where-
most of them.
did you get it?
There's a few that aren't like
Yeah,
that.
there you go.
Never really
Some
liked this
word
word.
different though.
All right, so we're gonna find the Jacobian. This is commonly listed written as J.
Since I watched it, that was. I remember to watch this.
Oh my gosh, it's bad.
What this means is we're effectively, if we have R as a function of X and Y, we're gonna do dr du cross dr dv, where R is in term is X of uv, Y of uv. An easier way to remember, at least especially the 2D one, it's just making a it makes it, well, I did this in the video, but let's write it out here. We're gonna go dx du dx dv 0. And then we're gonna go dy du dy dv 0. Well, these are connected. That's not the exact same thing. They're connected. This is the Jacobian. So if we go along K, K is the only one that's really going to have anything, right? I and J are going to zero out because of these zeros. K is going to have,
What was the other thing?
my bad, that's a Y. Another way of writing this is just the 2D matrix.
No, no, mental.
Where did you get all these? Wow, get 2x over 2. Oh, never mind, that's not 2.
Those are D's, those are partial derivatives, not 2's.
I don't know how you write 2s. Some people.
Oh, they
write
actually
2s.
do almost look like two.
Some people write really weird 2s.
There are some really weird two.
Yeah, a lot of people do 2's like that. I try
That
to
is
make my 2's clear. I
That
avoid the
looks
loopy thing.
almost like an alpha now that I'm thinking about it.
That's good to know.
Oh no.
So one way to remember it is the XY stay in order on top. The UV stay in alphabetical order for the first one, but switch for the second one. I don't know how helpful that is. Or you can just remember that it's what it is, where they're doing the partial derivative of X with respect to each variable across this, and the partial derivative of Y with respect to each variable across this direction.
What is connecting?
To understand it. The U's on the U's and V's are verticals,
No.
but
The right function is U equals something X, Y.
oh, those.
Yeah, we haven't
So-
used those yet. Let's use those.
So
I was
those-
pointing out what the Jacobian is. So we can't use these as is, can we? I can't take the derivative as is, so I need to rewrite these in terms of X and Y. So how can I do that? If I, that's a 4, that looks funny.
I don't know.
If I do u plus 3v, I've got 4x plus 3y plus 9x minus 3y.
Angular by making it simple.
Yo, what the hell?
So u plus 3v is 13x.
Oh, I
The
see.
way
So
I
you
chose
just,
to do that is I multiplied this by a number so that when I add them together, I got rid of y.
yeah,
I
so
would
you just got like
probably
a
write
common
it like
denominator.
this. It's not a common denominator so much. I would have written it like this. And then added vertically. So x gets me. All right, a little bit better. X is 1 over 13 times u plus 3v.
Yes, to get
So
yourself.
how about like 3?
I picked ugly numbers. This is shitty. I just randomly picked coefficients, and this is what you get when you randomly pick coefficients. So if I want to get rid of the x's, I could pick opposite coefficients. So I could do 3u and 4v. 3u gets me 12x plus 9y. 4v gets me 12x minus 4y. And then I'm going to make one of these negative. So if I do that, I'll change the signs there. And I get 3u minus 4v is 13y. So collecting all my shit together, x is u over 13 plus 3v over 13. And y is 3u over 13
Next call for X.
plus 4v over 13.
Results for X now.
But now I can get my dx du, dx dv, dy du, dy dv pretty easy. The partial derivative x with respect to u is just 1 over 13. The partial derivative with respect to v is 3 over 13. That should be a minus sign right there.
Factors of 113.
Then I've got 3 over 13 and negative 4 over 13. Wow. So this is negative 13 over 13 squared, or just negative 1 over 13. That was convenient. For randomly picked numbers, that simplified quite a bit.
So what exactly did you just solve for? Because
That's the Jacobian. This would be the correction factor.
Oh.
So if we, so the Jacobian is the correction factor.
That's essentially what the R would, if you did this in like a cylindrical coordinates, that would be what is R essentially. You put that into the function, it was changed to.
How many steps did,
instead of,
honestly, you're wasting your breath, and I have no idea what I say. Like, to be kind of say.
Oh, I think I have an idea.
It's a way to make your life easier, but make your life harder at the same time.
Well,
Making your life easier with
this problem is only 2D. That's the easier component. But I did want to remind you that most problems don't come in the form where you want them. So sometimes you don't have X and Y in terms of how you want them. And we just redid a little bit of algebra for you, because I know some of you are a little bit, is rusty a valid word? Rusty on your algebra, solving a system of equations?
No, we do systems of equations all the time in physics, but we just never do it
Not
like
everyone's
that.
in physics though. And still not everyone's does well at them.
Not everybody's Rob.
So I got one more to put up. I'll make it a take-home problem.
Bless you, sir.
Actually, no, we'll start with it. Maybe I'll show you it. But we'll solve it on tomorrow morning. Wait, Eric's still writing.
875.
Yeah, I'm good.
Oh, you're good? Okay. So
Thank you.
when we have a 3D Jacobian,
Okay.
and switching to the notation that people like, the partial derivative of x with respect to u, the partial derivative of x with respect to b, and w, then yu, yb, yw, and zu, zb, zw.
Yeah.
This is the Jacobian of UVW. And it's that.
He was like, oh, look, it's a cube.
And if you really want some practice, try this at home. Try this at home. Try doing the Jacobian with x equals rho cosine theta sine phi, y equals rho sine theta sine phi, and z equals rho cosine phi.
Yeah, I solve for y on both equations.
Do the Jacobian of rho
Look at it, and then if I feel.
Oh, yeah, that one's
Look at
not.
it, be like,
God.
I don't want to do this.
I remember doing the program for that semester.
We'll do this top one tomorrow, and then we're gonna do some more stuff.
I want to be. Yeah.
I did it, Mr. Krabs.
I'm not gonna remember
I'm just gonna read through the hard.
I did it. I got what he did on the screen.
So,
Yeah, I got the X. It's literally just systems equation.
so, we're gonna be
He
doing.
just
chapter.
circled every step. Sorry.
We're gonna be doing the chapter 14 test next week, right?
Look, I got it.
Yeah, next
And then-
Wednesday.
And then we're not gonna have the chapter 15 test until December 5th.
And then just solve the value.
Correct, I think. Let's look at the calendar.
So we're gonna be learning chapter 15
That's
for like
the 9
damn
months.
near a whole month, huh?
Yeah, well, it's pretty much.
Well, you got November. Think about Thanksgiving, and then we've got
Yeah.
Thanksgiving eats up half a week.
Yeah.
What's
And also, chapter 15 is the culmination of everything you guys learned this semester.
Right. Chapter 15 is all of your 3D physics shit brought to you via mathematics.
My average grade across all of the exams.
Sounds great.
So far, that's what we-
15 has got it's got applications. It's got real world applications to it.
Oh, it does.
It
Makes
takes
sense.
longer to learn. So I deliberately planned time for 15 to take longer because let's face it, chapter 13 and 14, most of these are just tools. A lot of you go, what the hell are we going to use these for? What is this good for? Well, it's good for the shit we're going to do in chapter 15,
Nice. Makes sense.
right?
Mr. Jones,
Yeah.
so basically chapter 15 is the final. Are you gonna count that as 70 or 30% of the, or 70% of our grade?
I think it's listed as 30.
Just 30?
I think the
Okay.
final is 30%.
Okay, thank you.
God, I can't even legally for 70% of your grade unless it's broken up over. All right, I'll see you guys tomorrow.
Have a good day, Professor Jones. How was your Halloween?
We have like only 6